Hey class, this week's lab is called the Ventilatory Threshold Lab. I wrote a fair bit about it, really just on this page, and some procedures down here. I do want you to read all of this before you come to class, but I'm going to try to summarize it as quickly as I possibly can. So, ventilatory threshold. Whenever we're exercising, we actually adapt by initially just taking deeper breaths. So here, if you look at breathing rate, like there really isn't a change in how frequently we are breathing, but like once we start getting to a really intense level of exercise, and mind you, this is aerobic exercise typically, we start exponentially increasing like how frequently that we're breathing. So hyperventilating is the term most people use for that. Now, there's actually two separate ventilatory thresholds that we're going to be assessing in class today. This VT1, if you've ever heard of someone talk about a talk test, that's more or less what VT1 actually is. So VT1 or ventilatory threshold 1, that is essentially when you're exercising an intensity that talking starts to be labored, and you can't really hold a conversation anymore. So once you're exercising, you're increasing in intensity. If you can't hold a conversation anymore, you've surpassed VT1. The second ventilatory threshold, which is actually quite a bit easier to measure, um, is really when you're increasing the intensity even more, and then you begin to hyperventilate. Now, there's a lot of really interesting stuff that we can surmise from VT1 and VT2. If you look over here, VT1 and VT2, it might not be associated with this until you start thinking about it, something called a respiratory exchange ratio. So all that is, this is a relationship of the carbon dioxide that you breathe out to the oxygen that you consume. How you can calculate a respiratory exchange ratio is just simply CO2 in the numerator and O2 in the denominator. And that would be if we actually collected all those values with open circuit spirometry. But we're not going to do that today because I don't think it's applicable for you whenever you leave here. But that ratio, if it's a 0.7, you're burning 100% fat, 0% carbohydrates. If it's a 0.85, it's 50-50. And if it's 1, then 0% fat and 100% carbohydrate. And actually, the amount of like carbohydrate relative to fat that you're burning, that actually dictates how many calories we're burning per liter of oxygen consumption. Because really, burning fat is actually slightly more efficient, so we burn a little less calories that way. Now, if you look back over here, VT1, which we're actually going to assess by a walking protocol, where you walk one pace that you choose, and we just increase the incline to increase the intensity every 2 minutes. And you're going to actually recite about a 90-word just thing that you know. It could be the Pledge of Allegiance, it could be Twinkle, Twinkle, Little Star, the ABCs, anything like that. Once you start having difficulty speaking, we're going to write that down as ventilatory threshold 1. And ventilatory threshold 1 is strongly correlated with a 0.85 respiratory exchange ratio, or R value. So once you start having difficulty talking, then you're burning approximately half fat, half carbohydrate. Then after we figure out that number, ventilatory threshold 2, we're going to do a separate bout for that where you're going to be running, and once you start to hyperventilate, we're going to write that down as your second ventilatory threshold, which you're burning 100% carbohydrate for that. So let's start looking at what you're actually going to have to do for lab today. Here's the procedures that I wrote. go on to Canvas and check all of that stuff out. It's going to be really fun in lab hearing people talk about Twinkle Twinkle Little Star and all sorts of stuff like that. Here's the protocol that you're going to do. Now, once somebody has like met what the point where they're having difficulty speaking, we're going to like fill out all of these values. So if you look back at Lab 1, I gave you the Metabolic Calculations Excel. This should help you a lot with this. So let's look over here, Metabolic Calculations. Now make sure you're on the walking one, and notice this only works if you're walking between 1.9 and 3.7 miles per hour. You can enter someone's body weight. Let's say they weigh 160 pounds. And here, let's say that they're walking 3 miles an hour, and they actually got their like VT1. They started having difficulty speaking whenever they were at like an 8 incline or so. So that means that per every kilogram of body weight, they're consuming 23 milliliters of oxygen per minute and 1.67 liters of oxygen per minute. Here, I'm going to close that for us really quick. Good. So if this was the case, hopefully you can see this well enough for me, for yourself. Yeah, I look at all sorts of weird things. Oh. Down over here. So you would have to calculate their height in centimeters. I don't know, let's just say that 165 centimeters, that's approximately how tall I am. 160, nope, I want that in kilograms. So this would be 72.57. If you're looking on over here with me, you're going to have to calculate the centimeters. Miles per hour, let's put 3 for percent grade, 8. Then down here, ml. So right there, that's how we're going to figure this out. So 23.12, that's good enough for me. And then VO2 liter, 1.677. So there we go. Good with that. Now, let's look back on this assignment. So once we figured that out, they're going to take a 5-minute rest. And then we're going to do the Vt2 protocol. Actually, let's go back on this just for a second. So I'm going to ask you a question. Using the R calculations listed above, how many minutes would it take to burn 100 calories of just fat? So some things you might have to like actually manipulate in here. So if you look back up here, 0.85, we would have to multiply the liters of oxygen, which is right here, liters of oxygen. We're going to have to multiply that by 4.86. So if you look in here, this kcals per minute, I have listed in there 5. That's a good average. But go up here and actually change that to 4.86. There we go. And since it's 50-50, we're going to have to enter some numbers in here until this becomes 200. So let's just say, I don't know, 30 minutes. That was close. How about 26, 24, 25, not 250, come on. Okay, so 24.5. So 24.5, and then you just divide that by 2. There we go. So it would take, at this pace, 12.25 minutes to burn 100 calories of pure fat, because here, that's the total calories. Up here, don't worry about this exercise alone type of stuff. You can just delete that for now. But that's all that would be. So if that was the pace that they're going, and then here, write something like it would take their name, whatever their name is, 12.25. Well, no, we can do better than that. 12 minutes and 15 seconds to burn 100 kilocalories of pure fat. Good. There we go there. Hopefully everyone is with me how we're doing this. Okay. Next, the Vt2 protocol. So have them rest for about 3 to 5 minutes. Expand that just a little bit. Have them rest for about 3 to 5 minutes and have them pick a certain speed. So it has to be over 5 miles an hour for this to work. And then just continue 2 to 4 minutes, 5 miles an hour, a 2 incline, 2 to 4 minutes, over 5 miles an hour, a 4 incline, and so on and so forth, until they really start hyperventilating. Let's say that they did it, still, however much this person is, 72.57. Let's say that they were going, let's say 6.5 miles per hour with how about a 6 incline? How about that? Okay, then come over to this, go to the running, and again here you can just delete all of that, go to the running, and 160, that's how much they are. Speed, if you enter 6.5%, grade, we said 6. Good. So they are at a 47.75 VO2 mils per kg, and here they're at a 3.4, let's go and round that up to 7 liters right there. So now we have their VT1 right here and their VT2. So down here, I'm going to want you to fill out this table. So how you're going to do that, you need to predict the values that are going to be for all of these. So here's how we do that. Have another Excel file, or you could just open up a sheet in another one. So here we already know that this RER value, we have the 0.85 and the 1 respiratory value, we have that. So now we're going to have to enter what their liters per minute were. So here it is 1.677, and then down here where the respiratory value was 1, 3.47. There we go there. Okay. Then what you're going to have to do is you're going to have to do a regression. So insert, you're going to have to make a little scatter plot. So here, insert scatter. There we go. Normal scatter right there. Okay. VT let's make all of these go away. I'm going to want you to supply me this graph. Okay. So here, this is just liters per minute, and it's oxygen. And then here, this is R value. Okay, so here, next thing that we need to do, add a chart element, go to trend line. Linear relationship, go and click on that. I'm going to make this full screen for us. So click on that. Just clicking on that dotted line right there, this should pop up. Linear. What I'm going to want you to do is click on this display equation on the chart. There we go. Okay, so hopefully you can see that equation. Let's I don't know, let's make this a lot bigger. Oh, too big. Okay, there. So that equation right there. So this is what I would enter. So R value. Sorry, there was thought someone was knocking on the door. So R value, you're gonna have to predict 0.75, 0.8, 0.85, 0.9, 0.95. You're gonna have to predict all of those. So enter this equation, and it's this equation right here, and you're going to have to predict your own. This is just a hypothetical one that I'm doing. So 11.953 multiplied by, click on that, then minus 8.4833. Okay, so this right here, that's the R value. This, we're actually predicting these liters per minute right here. So with that, you can literally just drag it all the way down and check that out. So the R value of 0.75, of 0.8, 0.85, well, like that should be really close because I actually did measure that. I am predicting all of these, didn't mean to do that, all of these liters per minute right there. Okay, so now let's go back over here to write all of these in here. So these liters, so this would be point, well, actually, you could likely just copy right there, paste all of that in there. That's how that works. So to convert that to this, what you would need to do is an equal sign. You have to multiply it by 1,000, and then you have to divide it by what their body weight was in kilograms. So let's look at where that was, 72.57. So here, 72.57. There we go, got that. All right, so then here, copy that, and what you could do for all of these is decrease the size a fair bit. That'll make it fit a lot better. So there, I just copied that, Control or Command C. Put all of that in there. So far, so good. Now what you're gonna have to do is figure out a speed and a percent grade for all of these to work. So for this 0.75 and this 0.8 and this 0.85, well, you should already know this one. You should already know this one. It was 3 and an 8. So that should help you a fair bit because you already measured the 0.85. You're going to have to go over here to the running equation and start entering values that would work to give you this value, and so on. So here, let's see. Let's see what will work. So a 1.4 right there. Oh gosh, well, like, yeah, no, like we need to drastically decrease that. So how about a 0? Okay, so there we put a 0 in for the grade, and then we got a 0.8. So we need that even lower, so we might need to decrease the speed even more. 0.48. Okay, well, that's pretty close. So here we would write 1.15 and a 0. Now granted, this is really only for speeds between 1.9 and 3.7, so this is likely inaccurate, but you know, like it might be able to get us something. Now here for the 0.8, we need a 1 right there. So let's put a 3 right there. All right, that's at a 0.8, maybe a 2, maybe a 2.5, 1.8, 2.4, 2.3, 2. There we go. So like 3 miles per hour, 3 miles per hour with a 2.3 incline, right? Which that really wouldn't happen. So maybe we don't do that. Maybe we leave it at, say, a 2 incline, and we actually increase the speed to 3.2 miles per hour, 3.1 miles per hour. Let's see. That's fairly close. So we could be at 3.1 miles per hour with a 2 incline. See how that works? And now for the running ones, for 0.9, 0.95, and a 1, you would have to go over here and do this. So we want a 2.27, so we need that to be quite a bit lower. Let's see if we could just get it there by doing this. Okay, so we decrease the incline. How about a 0? All right, 2.27, decrease the incline to 0. We're at a 2.78. How about 6? 5. Okay, so 5.5 might work for us. 5.4, 5.3, 5.2. There we go. That's pretty good. Okay, so 5.2 with a 0 incline, that would get us to a 9 R value, which if we really wanted to, we could calculate, you know, the calories per minute if we just modulated all of this to a 4.92. Pretty good stuff. And just so on and so forth. You'll kind of just guess and check for the rest of these, and then you'll explain like how you could apply this to different tests. Hopefully this video wasn't too long. Pretty fun stuff, I think. All right, see you in the lab.